So in this problem, we're going to test the claim that there is a linear regression between the average temperature versus the gas consumed for the house that just had insulation installed. We're going to test this at the 5.05 level of significance. So again, we have our data that we've been working with. The first step of every hypothesis test is to state your random variables. There are two in this case, the average temperature and the gas consumed. The next step of every hypothesis test is to state your hypotheses. In this case, we are testing our correlation coefficient. So the symbol for the correlation coefficient is the Greek letter rho. HO is always that rho is equal to something. In this case, no correlation would mean that you have a correlation of 0. So rho equals 0. Our alternate hypothesis, in this case, because all we said is there a correlation, all we care about is there one? We didn't say is there a positive one or negative one. So if we're just looking to see if there is a correlation would mean the correlation coefficient is not 0. And then we are testing at the level of significance of 0.05, so let's go ahead and state our alpha level here. So there's our second step of our hypothesis test. The next step of our hypothesis test is to always state and check your assumptions. In this case, we have our first one is number 1 is a random sample of 18 pairs of average outside temperatures and gas was taken. So that's the stating of the assumption. In example 10.1.1, we actually did state and plot up it actually stated, that the data was collected from random days. So we do in fact know that we were collected from random days, so we do have a random sample. The second assumption is for every value of the independent variable, in this case average outside temperature, the dependent variable is normally distributed. What this looks like is if you look at a scatter plot here and you look at your regression line, it's saying right here for that value of your independent variable, if you were to plot up all the y's, you'd get a normal distribution, and you do that all along the regression line. And that's actually very difficult to try to figure out. So it turns out we can actually just look at the scatter plot. As long as the scatter plot looks fairly linear, you're good. And from 10.1.1 example, we did notice we had a fairly linear looking scatter plot. And then the residual plot has to look kind of random where there's no pattern to it. And in example 10.1.3, we actually looked at the residual plot and it did look kind of random. So the assumptions are met. Alright, then we're going to go do our test statistic and our p-value, our calculations. Again, I'm using R for this. Again, it's more about understanding what a printout would look like. In this case, when you do the correlation test, and it's actually core.test, and then your independent variable, comma, your dependent variable, and it is in that order, independent, then dependent, you will get this printout, this output from R. So first thing I notice is that I have a t-value here. That's my test statistic. So my test statistic is negative 4.5144. My degrees of freedom are 16, in case you want to know that. And it does in fact give you the p-value. So we are told that our p-value is 0.00035, let's say. It does actually tell you that the alternate hypothesis, true correlation, is not equal to 0, so it just tells what we actually typed in. It gives you a confidence interval for your, that's actually for your correlation, for your slope, I'm sorry. And then it does give you your correlation, which is right here. We already calculated that, and that was the same value we came up with before. So now we can move on to our conclusion. Since our p-value is smaller than our alpha level, we can in fact reject HO. So we are going to reject HO since my p-value, which is really small, is less than my alpha, which is my level of what do I think is unusual. And then we can move on to our interpretation. If we reject HO, remember this means we have in fact found enough evidence to support HA. So that means there is enough evidence to support HA, but HA says a correlation between average temperature and gas consumed. So we did say before we thought we had a moderate correlation. This actually shows that there is in fact enough evidence to show there is a correlation between these two. And so this gives us information and tells us that we should be doing what we're doing.